A second example. It says in a given triangle ABC, so look ABC, they're saying in the given triangle ABC, AB, the distance from A to B is 3 centimeters. So look, A to B is 3 centimeters. They're telling me what I already see in the picture. A to B is 3. And the size of these lines mean the size of angle ABC is 90. So ABC, this angle here is 90. They tell me that D is a point on BC. So B to C is along here and D is on it. Oh yeah, I see it. D is on the line B to C. And A to D, the distance from A to D is equal to the distance from C to D. So they're saying A to D is the same as C to D. And these little marks here show you that they're the same length. If D to B is 4 centimeters, oh yeah, they're telling me this, find A to D, and then angle ACB. Okay, so let's call A to D X and mark in an X on our diagram. We want to know the length of this guy here. And then they want us to find out angle ACB, this angle here. I'm going to give it a new name. I'm going to call it angle theta. So let's call this theta. Now, a bit like example 1, how do we approach a problem like this? Whenever you have a problem like this, we want to chop this shape up into triangles, preferably right angle triangles. Now, if you look carefully, there's a small right angle triangle here. So I'm going to draw that on its own. So that's A, B, D. There's one triangle. I'm going to fill in all the information on that triangle. I know the height of this is 3 centimeters. I know the bottom of it is 4. And then this is called X, which is one of the things I'm looking for. Are there any other right angle triangles? Well, this white triangle that's left here is not right angle. Let's draw it anyway. I've got a triangle that looks like this, where this is the same as that. I'm going to put the letters in A, D, C, and this is angle theta. But that's not right angled. So it's not really going to help us here because I have not taught you how to do non-right angle triangles. Is there another triangle I could draw? Well, the answer is yes. It's the big right angle triangle on its own. So I'm going to draw that on its own. Like so. A, B, C. I can put in a theta here. I can put in 3 centimeters here. And I don't know the length of the bottom. Okay. Now, which of these 3 triangles has the most information? Well, it's this one. So let's work on this one first. Can I use this triangle to find out what X is? Well, yes, I can. Now, how do I do it? Well, because it's a right angle triangle, I am allowed to use SOHCAHTOA and I am allowed to use Pythagoras' theorem. Will Pythagoras' theorem work here? The answer is yes, because I know 2 of the sides. So let's use Pythagoras for this one. And Pythagoras' theorem says that h squared is always equal to o squared plus a squared. So let's label our triangle. If this is my right angle, this is h. Now, because I don't know any of these angles here, it doesn't really matter which one I call O or A. So I'm going to call this one O and this one A. The most important one is getting your h right. So h is x in this one, so it's x squared equals O, I'm saying it's 3, so 3 squared and then 4 squared. And we just work this out as normal. And I get x squared is equal to 25. So x will be the square root of 25, which is 5. So I've just worked out my first answer, by the way. Answer part 1 is, now x, I called it x, but the actual answer is A to D. A to D is 5 centimeters. Notice I put the units in as well. There's one of my answers. Now, we always update our pictures. So, in this one here, this is 5 centimeters now. In this picture, this is 5 centimeters. And by the way, this would be 5 centimeters. So this is 5 and this is 5. Could we use this new information to update this picture? Have a think. Could I work out the distance from B to C now? Could I write down the distance from B to C? Well, look at this. Could I work out the distance from B to C? The answer is yes. I've just figured out that this side is 5. I'll highlight it. This side is 5. And that's the same length as that side. So that's 5. And look, the distance from here to here will be 4 plus 5, which is 9. So I know that this is 9 centimeters. Now, to finish this question, I need to find angle theta using this triangle. And because I now know another side, I'm able to work out angle theta. And how I do it is by labeling this triangle. If this is angle theta, this is O, this is A, and this is H. I know what O is, I know what A is, so which one am I going to use? Sine, cos, or tan? I'm going to use tan. So I'll write it here. I'm going to say the tan of theta is O over A. So the tan of theta will be 3 over 9. And then just down here, theta will be the tan inverse of 3 over 9. And we can do that in a calculator. So we go shift tan 3 over 9 equals, and I'm getting 18.43 degrees. Now, the answer wants, it will go at one decimal place. So I'm going to rewrite it as angle ACB, because that's what we call theta, is 18.4 degrees, and there is my second answer. So this question was a little bit more challenging, but you can see the approach. We try and chop the triangle into various different triangles. We look at the triangle that has the most information and figure out something new. We update all our pictures, and hopefully that gives us a clue for the next picture, and so on. We're always using Pythagoras' theorem or SOHCAHTOA if it's a right angle triangle.